Hello, today is the fifth day of our Arduino class. We're going to learn how to use an ultrasonic sensor today. For the ultrasonic sensor, we are using the HSC SR4 model with 4 pins. Introduction. A sensor is a device which detects physical change and records it in the form of signal. An ultrasonic sensor measures distance between itself and an object by using ultrasonic sound waves. Here's a diagram. As you can see, there are 4 pins on the HSC SR4, one being VCC, the other being trig, echo, and ground. An ultrasonic sensor emits sound waves, then it waits for the sound to be reflected back after hitting an object. It measures time this whole process took. To make the ultrasonic sensor emit sound waves, we set the trigger pin as an output when we code, activating the transmitter. To make the ultrasonic sensor receive sound waves, we set the echo pin as an input when we code, activating the receiver. Our project will do the following. It measures the distance between the ultrasonic sensor and an object. It turns on the LED when the distance is shorter than 10 centimeters, turns off the LED when the distance is longer than 10 centimeters, and it shows the distance on the serial monitor every 0.5 seconds. Circuit. Here are materials necessary for this project: Arduino Uno, ultrasonic sensor, breadboard mini, 1000 ohm resistor, jumper wires, blue LED. Make sure that you use breadboard mini. This project does not require power columns nor ground columns. Here's the circuit. For the ultrasonic sensor, VCC on the sensor is connected to 5V on Arduino to give power. The trigger pin on the sensor is connected to pin 13 to send out a ping. The echo pin on the sensor is connected to pin 12 to receive reflective waves. The ground pin on the sensor is connected to ground. For the LED, the anode is connected to pin 12. The cathode is connected to ground. Background knowledge before coding. Long variables are extended size variables for number storage. The constant keyword stands for constant, which means the value of a variable with this keyword cannot be changed. For example, constant int pin number equals 13 semicolon. This means a variable pin number has a value of constant integer 13. The serial monitor is a pop-up window that allows your computer and your Arduino board to communicate with each other. In this project, you'll use this feature to print certain data sent by your code. If you have ever done Scratch, you can imagine a stage which shows the direct result of your coding blocks. Click this to open the serial monitor. A blank window will pop up. Serial.begin. Serial.begin opens the serial port and sets the data rate of serial communication in bits per second. Bit is a unit of information. In this project, you'll assign the rate to be 9600 bits per second, so it'll be serial.begin 9600 semicolon. Serial.print. It prints the data to the serial port. So for example, serial.begin, serial.print 100. This will print 100 on the serial monitor. Serial.print line prints data to the serial port and it begins a new line. pulseIn. pulseIn pin high waits for the pin to go from low to high, starts timing, then waits for the pin to go back to low and stops timing. It basically measures how long the pin was high. pulseIn pin low waits for the pin to go from high to low, starts timing, then waits for the pin to go back to high, and stops timing. It basically measures how long the pin was low. It returns the length of this pulse in microseconds. Because pulseIn returns the duration of a pulse in microseconds, we have to convert it to centimeters to solve for the distance between the sensor and an object. By using the speed of the ultrasonic signal, which is 29.1 centimeter per microsecond, we can convert microseconds into centimeters. So distance equals duration over 29.1. But the pulse measures the duration of a ping both transmitted and received. So if you directly convert this duration into distance, you're counting the same distance twice. So it has to be divided by 2 at the end of calculation. So real distance is duration divided by 29.1 divided by 2. Now let's move on to coding. First, we're going to create 3 constant integer variables to assign pin numbers. Const int trig pin equals 13. Const int echo pin equals 12. Const int LED equals 11. As I mentioned earlier, the trigger pin is going to act as a transmitter, and the echo pin is going to act as a receiver of a ping. Now for the setup function, we're going to begin our serial monitor at the rate of 9600 bits per second. So Serial.begin 9600 semicolon. And we're going to assign trig pin as an output so that it can send a signal when it's high. Pin mode trig pin output. Then we assign echo pin as an input so that it can receive and read the reflected signal. Echo pin input. Then pin mode LED output so that it can be bright when it's high. Now the loop function. Let's establish our main variables with a big range of integers. Long duration, long distance. Okay, now we're going to deal with the trigger pin. We'll give a short low pulse before we give a high pulse to ensure a clean high pulse. So it'll be digital write trig pin, short low pulse, right? So delay microseconds, maybe 2. Then let's give a high pulse to send out a signal. Digital write trig pin high, delay microseconds 10. Now let's turn it off again. Digital write trig pin to low. Now the pulseIn function will be able to do its job by measuring for how long the echo pin received this trigger pin signal. We'll assign this value to a variable called duration, which is in microseconds. So duration is equal to pulseIn echo pin high. Then we'll use the formula I mentioned before to convert duration into distance in centimeters. Distance equals duration divided by 2 divided by 29.1. As I mentioned in our project idea slide, we turn on the LED only when the distance is less than 10 centimeters. So we'll use an if statement here. If distance is less than 10, digital write LED becomes high, and otherwise digital write LED goes low. And we'll make sure that this distance in centimeters will appear on the serial monitor every 0.5 seconds. So Serial.print distance and Serial.print line centimeters. and every 500 microseconds. Delay 500. Now verify it. You can unload the code and open the serial monitor. If the serial monitor prints the distance between the sensor and an object every 5 seconds, and depending on the value of this distance, the LED light constantly turns on and off. There, we made it. Here's our finalized code. If you have any question, please ask me during the meeting. I might ask you some questions too to see if you guys can be flexible about what we learned today. Thank you.